Hello everyone. Today we are going to discuss about the different trade-offs while designing an application. The first one comes is availability. Mathematically means that it is uptime by uptime plus downtime. For example, we have a server and it is available per 23 hours by 24 hours. Then it is available 96% of the time, right? So a server or a service will have uptime and downtime. Based on these two things, an availability is calculated, which means how much percentage of the time the service is available to the users, right? Now coming to the next two terms, which are SLA and SLO, which means service level objective and service level agreement. For example, we have a service and there are certain users who are using that service. Before using that service, the users will make an agreement, and the agreement will have an objective, which is if the service is not available for the 99% of the time, we will be having 30% discount for the users, and this is included in the agreement such that users will make this agreement, and if really the service is not available for the 99% of the time, the users will get 30% discount on our service pay, right? This is what is meant by SLO and SLA, and the service level objective is a part of SLA, which is the agreement, right? Now coming to the next term, which is reliability, which means that the probability or the percentage of confidence which the system would not fail, right? For example, we have a service S and we are guaranteeing the users that service will not fail 96%. So this percentage of confidence will be required for the users to trust our application, right? For example, we have a server S and multiple users are requesting it, and the service is failed, and our reliability is disturbed. So instead of it, we will vertically and horizontally scale our application and increase the reliability of the server and keep our users engaged, right? That is what is meant by reliability. Now coming to the next term, which is fault tolerance, which means that in case of failure and if a failure occurs, what are the safety measures we take, or what are the safety measures provided in case of a service failure, right? For example, let us see, we have a server and a database here. Assume that the server and the database is failed and the user which are using the service have been interrupted. This happens when the load is increased and the writing operations or reading operations on the database are increased. So if this fault happened or if this failure happened, what is the tolerance or what is the measure we will be providing, right? So assume we have a redundant or extra server and extra database for a backup. So if these two servers and database are failed, then the user will be forwarded their request to this server and this database. So the user will not be interrupted. And this is what is meant by fault tolerance, right? Now, the next term is redundancy. Duplication of an application or a function. On the above example, we can see we have duplicated the server and database to increase the reliability and fault tolerance, right? So we are here duplicating the server and database. By this, we are using the redundancy principle, right? Now let us get into the next term, which is throughput, which means, for example, there is a server. The throughput means how many concurrent requests or how many concurrent queries a server can handle. For example, there are 10 users who are requesting at a time the server, and the server is responding with a good response. Then the server is handling 10 concurrent requests at a time per second. For example, the users are increased and they are increased to 15 and the server has been crashed. Then it cannot handle 15 requests per a second. So the throughput is not that much good. And similarly to a database, how many queries or how many concurrent queries per second a database can handle. This is usually measured the number of concurrent requests or queries per a certain time. This is what is meant by throughput. Now let us get to the latency. Latency is the time or the percentage amount of time which is taken by throughout request. For example, a user has requested for a resource to the server, and the server has responded with a response with the resource, and it took 2 seconds for the server to complete this whole process, right? So this is the latency, the amount of time taken for the user after clicking the button or after requesting the resource again to getting the resource, right? For example, there is a use case where a single server is there throughout the globe, and there are different users throughout the globe. And if the request is headed to that single server, it take different times. For example, he is from a north side, and it takes 1 second for the request, and he is from the south side, and it takes 10 seconds for the request. So based on the distance and based on the network availability to the server, the latency is changed. So we will use a concept known as CDN, which is content delivery network, which means that we'll deploy our service or we'll make our service redundant through different servers around the globe. For example, here we can see there are two servers here, and we are making our service redundable throughout the globe. So if a user of this site request, it will take to this server and will be 50 ms, which is 50 milliseconds. And if the user of this site requests the server, takes 50 seconds, and the latency is not decreased or disturbed. So using the CDN, we can increase the latency. So these are the terms which are very important while designing an application. One may be increased or one may be decreased. Based on our use case, we have to use case our application, and will design the application throughout the trade-offs. Thank you.